C, a foundational programming language that has powered the digital age. Developed in 1972 at Bell Labs by Dennis Ritchie, it's the mother of many languages we know today like C++, C#, and Java. Originally created to re-implement the Unix operation system, C has been the heart of system programming, embedded systems, and even game development. It's known for its speed, portability, and close proximity to machine hardware, making it the go-to choice for high-performance applications. At its core, C is a procedural language focusing on functions and procedures to operate on data. This makes it both powerful and at times intricate. Variables in C have explicit types, such as int, float, and character. Memory management is manual, leveraging malloc and free functions, giving developers fine-grained control over system resources. Control structures like loops, for and while, and conditionals such as if and switch form the backbone of C's logic flow. Functions play a crucial role. They can be defined with return types and can accept parameters. For example, the reown printf and scanf are standard library functions used for I/O operations. C's power also comes from its ability to use pointers, which are variables that store the memory address of another variable. While they can be tricky, pointers provide a way to work directly with memory, enabling advanced data structures and efficient algorithms. We cannot discuss C without mentioning its preprocessor directives, starting with the route symbol. Things like route include and route defy allows for modular code and macros. The language also supports structures, struct, to group variables of different data types together, and unions to save memory when working with variables that can't be used simultaneously. In terms of extensibility, the C standard library provides a suite of functions from string handling to mass operations. Moreover, there's a vast ecosystem of open source libraries that expand C's capabilities even further. While C is fast and versatile, it doesn't come without challenges. Memory leaks, pointer arithmetics, and buffer overflows are potential pitfalls developers need to watch out for. The language closeness to hardware means that understanding the underlying architecture can be crucial for optimizations. Concepts like cache memory, memory alignment, and endianness comes into play. C has a compiler-based workflow. Source code written in .c files is compiled to produce an executable. Tools like the GCC are commonly used for this process. In summary, C is a legendary language, foundational to the realm of programming. Its legacy is evident in the system it's powered and the language it has influenced. Whether you are aiming for system programming, game development, or just to understand the underpinnings of modern computing, C is a language worth mastering. If you found this dive into the C language enlightening, hit the like button, drop your thoughts in the comments, and don't forget to subscribe for more tech insights. Thanks for tuning in, and I'll catch you in the next episode of ILTPWC. Thanks for watching.